Welcome to the AI Research Roundup. I'm your host, Alex. Today is May 3rd, 2025. Okay, so today we're diving into this ICLR conference paper, Self-Improvement in Language Models, the Sharpening Mechanism, published back in January, just over 3 months ago. This paper looks at how language models can improve themselves, without external feedback. They call this, quote, sharpening, basically using the model's own ability to verify good answers to unlock hidden knowledge. Alright, so looking at figure 1, this really backs up the sharpening concept using what they call best-of-n sampling during inference. We see in panels A and B that taking multiple samples and picking the one with the highest likelihood often improves accuracy over just taking the single best guess, especially as n increases. Panel C is interesting. It shows correct answers generally get higher probability scores from the model itself, suggesting this verification ability is real. Okay, so figure 2 here dives a bit deeper into different ways to pick the best answer beyond just the highest likelihood, like using length normalized probability or even majority voting. Panels A and B show these alternative methods often give a nice accuracy boost compared to just taking the model's first guess, which we see in panel D. In panel C, the pass at 5-0 accuracy really highlights the model's coverage, showing it frequently generates the right answer within 50 tries. Okay, building on that, figure 3 gives us a broader view across several different tasks, like math, GSM-8K, and others. It plots the percent accuracy lift from using best-of-n sharpening over the standard greedy output. As n, the number of samples, increases. We can see from many models tested, like the Phi 3 series and even GPT 3.5, accuracy generally climbs with n, really showing this inference time sharpening works effectively across the board. Okay, so moving to Table 1, this shows experimental results specifically for SFT sharpening. Remember, that's where they fine-tune the model on its own high-likelihood answers. We see models like Phi 3.5 Mini get a nice accuracy lift, over 19% on the math dataset, compared to the standard greedy output. This suggests that the benefits we saw from inference time sampling can actually be partly baked into the model through this SFT approach. Alright, so figure 7 gives us a closer look at how that SFT sharpening process unfolds over time for the Phi 3.5 Mini model. Across datasets like Math and Pronto QA, we see the accuracy lift compared to greedy output generally increases during fine-tuning, shown by the blue lines. However, it doesn't quite reach the full potential shown by inference time sharpening, which is that dotted orange line. It confirms SFT helps, but doesn't capture all the gains. Building on that SFT sharpening idea, figure 9 zooms in on the effect of n, the number of samples used to pick training data, for Phi 3.5 Mini on the math dataset. Panel A plots accuracy lift, Panel B plots log probability lift, both versus training checkpoints. We clearly see that using more samples, like n equals 50 compared to n equals 10, results in a bigger improvement in both metrics. This suggests more sampling finds better data for fine-tuning. Alright, so to wrap things up, the core idea here is, quote, sharpening. Language models essentially contain hidden knowledge, and they can use their own ability to verify good answers to improve themselves. We saw this works with inference time sampling, like best-of-n, and also that SFT sharpening can bake some of those gains directly into the model itself. It provides a solid framework for understanding this self-improvement phenomenon. That's all for this AI Research Roundup. Thanks for listening.